Every encrypted file stolen today is a ticking time bomb. And that's because quantum computers might one day be able to actually decrypt those without any problems. And if you want to learn more about this specific problem, as well as about a company that is aiming to solve this in today's world, then you are exactly right for today's video, as we are talking about Arqit, or the Arqit Group, which is a company that is preparing the world with post-quantum cryptography solutions. But before we go into that, a quick announcement here. So Arqit is a stock traded company, so you can invest into it or you might not. This is all completely up to you. So just as a quick announcement, this is not investment advice. I'm not giving any advice for buying or selling this specific stock. I'm just reviewing the company with my potential interest and let's say fascination for quantum technology. All investment decisions are completely personal and up to you. And now with that, let's get right into it. So here we are on the website. It says Arqit up here. Arqit is one of the, let's say, earlier companies in the quantum space to do an IPO, and they are only exclusively on the software side. So they are using software, so-called post-quantum cryptography methods, to protect against quantum threats. So let's see quickly what they are saying here. Your data is everywhere. Advisories are harvesting encrypted traffic now to decrypt later. So that is the harvest now, decrypt later idea. Cloud and AI intensify data sovereignty pressure. 5G and edge expand the attack surface. Post-quantum cryptography, short PQC, migration deadlines are approaching. And we will see these later on. Arqit gives you the visibility, controls, and quantum safe protection to secure it today. Then we see here this hand with the glowing ring in it. Not sure what that means. And we see a couple of partners that are already using or that trust into this. So you see here, I think that's some national agency. You see Intel, Juniper Networks, Oracle, and many, many more over here in the list. So then there's some explanation here. So the thread is already there. Harvest now, decrypt later. So the idea of this harvest now, decrypt later is exactly what I said, right? If you are sending a file today that is encrypted, for example, with your health data to your doctor, to your clinician, whatever, then somebody might actually sit in between, eavesdrop on that message, so copy it somewhere, and then when the quantum computer is out there, they can decrypt that. So I'm taking your health data because this data is something that you probably want to keep for yourself until the end of your life and not share with the whole world, right? So there's certain data that has a pretty long time span in terms of its secrecy, which is not true for all of the encrypted data, but that you actually want to keep secret, and we never know. Maybe the quantum computer will still happen in our life that could potentially decrypt that. The timelines on that are very different depending on whom you ask. Expanding attack surface is what they said before, right? More devices, more endpoints in the internet, potentially more surface to do that, and compliance pressure. So you see there's UK, EU, US regulatories that are already happening, and we will see those later on as we go through their website. So how do they actually solve it? I mentioned already it happens on the software side, right? So first of all, detect with encryption intelligence, see where cryptography lives across your estate. So basically figuring out where you're actually using cryptography, find weaknesses and quantum vulnerable protocols, and generate a prioritized migration plan backed by continuous discovery. So creating a plan, and that probably does not target so much the private users, because I mean we are anyways using so many different services and so on. This is more for the corporate users that actually need to keep track of all their digital assets, of all the communication and the encryption protocols being used throughout the organization. Then there's this point here about protect, right, with network secure and SKA platform. So we'll learn about that later on. Harden VPNs, VPN tunnels, you know already today, right? These are encryption methods to protect your, for example, internet connection. So harden VPNs and critical links with on-demand encryption keys layered with standard aligned cryptography, no rip and replace. So basically integrating into existing workflows, right? Works with major OEMs and open interfaces. We will see a couple of those later on. Then comply with audit-ready evidence, right? We are talking about the legislation, the new rules coming up. So with those, of course, there's audits coming up. So track proven protocols and keep pace as PQC guidance and sovereignty obligations evolve, grounded in discovery data and operational telemetry. Then the 5 pillars of quantum security, I will just briefly go through that: confident computing, data sovereignty, encryption intelligence, 5G secure networks, post-quantum cryptography. We will not go into the details because we have talked about those in previous videos already. If you haven't seen those, go visit our YouTube channel. There's a Hidden Quantum Champions playlist which lists all of these videos. Then trusted by leaders. Here already we see the Intel logo, and we will see a couple more later on. Then we see here telecoms, governments, and CNI, and then defense, of course, also as a major user of this encryption upgrade, right? Robust protection against 21st century security challenges, and then down here we just see the typical GetHatch and social logos. Now let's quickly hop into the migration. So they are basically clustering the process in 3 different solution processes: first detect, then protect, and then comply. And you can see here it jumps back and forth between detect and comply. So we will learn a little bit about what this actually means down here. So what encryption intelligence delivers: discovery, identification, prioritization, migration, and monitoring. So this is the process of how to go from today's, let's say, not quantum secure organization all the way to building this organization, but in the most effective and most efficient way, right? So that's the prioritization and the migration that is happening here. Choose your path, and here it starts to become actually interesting. So you see the different steps here, and then down here, and I think that is something that is worth pointing out, we see the regulatory timelines of the different legislations that have been touched before, right? UK, EU, and US. So February 2024, the EU came with the AI Act, and the AI Act, of course, mainly covers artificial intelligence, but also has implications on cybersecurity standards. So that's already the first one where it starts to attack, right? Then in January 2025, we see DORA, which is again the digital, what is it? Some digital, the D's for digital, digital organization, something act, I guess. So again, EU legislation for digital communication, or well, for digital legislation. Then we see the EU Data Act here in September 2025. And now starting from 2026, so I'm recording this video in 2026, the EU member states adopt national post-quantum cryptography strategies. So this is already in the process of happening. There is national standardization ongoing, and there's more information down here. So member states are expected to launch national strategies by end of 2026, secure high-risk systems by 2030, and aim for broad migration by 2035. So this is the, let's say, timeline on which the European Union sees potential risks of quantum computing. So the idea is 2026, end of 2026, we come up with all the different ideas of the member states. 2030, the high-risk systems, so again, cybersecurity, infrastructure, things like this, governmental organizations, they might have to be protected. And then by 2035, every service should be protected against that, because from here we see an increased risk of these quantum attacks to actually happen. Now in 2030, again, we see priority systems here in UK, US, and EU must migrate from vulnerable algorithms. And here we take a look again at the national ones of the additional 2 nations that we see here, UK and US. In the UK, it says the National Cybersecurity Center, NCSC, recommends that priority systems migrate by 2030 with full migration by 2035. So this is again aligned with the migration strategy that the European Union is suggesting. Looking at the US, we see here NIST and federal policy measures envisage phasing out quantum vulnerable algorithms by 2030 with full replacement under certain mandates by 2035. So again, full replacement by 2035 and quantum vulnerable algorithms by 2030. So that, let's say, is a little bit of a different view that is more on the algorithms based. So 2035, to summarize, should be a broad global adoption of quantum safe cryptography, and it says here additional legislation is anticipated in all jurisdictions. So that's, let's say, on the legislation side of things. And now let's talk quickly about the way that this has been done, or the way that Arqit is suggesting to do that. And this is using the SKA platform. So Arqit's SKA platform unlocks a new era of quantum safe communication across network devices. SKA platform provides robust protection against the spectrum of current and future cyber. Now, there's a lot of explanation here. I will not go into all of the details of how that works, but I think this graph here kind of explains how the setup works. So you have your existing, let's say, application interfaces, right? So you see here user physical virtual devices down here, and they communicate with each other via these hardened communication channels that are using this post-quantum cryptography encryption schemes. Now, how do they actually use those, or how are these actually protected? Well, that happens, of course, with cryptographic keys, and this is where this Arqit agent comes in, which you're seeing up here, which provides the key that is being used. And those keys, they are being exchanged via this Arqit SKA platform. As far as I understand, this is a proprietary algorithm that is being used to do this kind of key exchange between two parties in a, let's say, zero trust manner. And then, of course, there's some more explanation down here. So create quantum safe keys at the endpoints, scalable, flexible platform, and so on and so forth. But I'm not going to go into all of these details for now. Network security, this is then the final point, right? So integrated, automated, on-demand quantum safe protection of VPN data communications. So again, as mentioned already before, the channel at which this is going to happen, the communication channel that might be easiest to integrate, is this VPN, virtual private network kind of setup that you already know from today's architecture, but of course with a quantum hardened setup. Then here you see a couple of networking partners, and I think this is pretty strong as well. Looking through the labels, you might identify a couple of those that you've heard of before, like for example Cisco, as I think one of probably the world's biggest network providers. Here again, some explanation of what it looks like. I think we've talked about that before, right? You have these services, firewalls, the data connection, you have the key, and the key exchange via the cloud network, and that's basically how this is all set up. Here's some more details of the exact protocols and so on and so forth. So that is more or less, let's say, the inner workings of it. When it comes to the sectors, I think we've talked about that already briefly, and it doesn't come too much as a surprise that, of course, you're talking about defense applications where, okay, those secrets you really want to keep secret because, I don't know, if the nuclear keys are being exposed to a malicious actor, that's a bit of a problem. Government is also kind of clear. US markets, I guess that targets the financial institutions and then telecom providers, because whenever there's communication between end parties, of course, it makes sense to help or to secure the telecommunication provider or the communication provider, be it post services that have to send letters back and forth in a safe way, or be it people that are using phones, or be it emails that are being sent back and forth, right? It all goes through these communication providers, from communication providers, and there it makes sense to help them to protect, because that way you can cover a lot of the communication already. On top of that, there's a lot of resources provided here. So you see white papers, a blog, you see product sheets, case studies, and so on. I'm not going to go into the details of all of this because I want to keep the video, at least for now, the video is a little bit shorter. And I mean, let me know if you like this idea or not down in the comments below. So that's basically, let's say, for a different time. If you are interested in that, check out the resources. There's more information here about how the approach works, about the technology in its basics, but I want to quickly take a look also at the company, as I do per usual. There's a video here which I will skip, and then you see here the executive team. So again, this is a stock listed company that has done its IPO, so this is not 5 people that are sitting in a university lab or in a garage that are building something, but actually like a proper company setup. And that's also what you can see here when you're looking at the team. So you have an executive team here of all kinds of business roles. So you see chief product officer, revenue, financial officer, but also, I don't know, chief operating officer, chief people officer. So you see all the different roles, right? You also have board of directors here. So as I think per usual for stock listed companies like that one. And then there's a list of all the awards that they have been receiving, as well as trade associations and accreditations down here. There's also a huge partner network. There's actually quite a couple of partners. I will quickly scroll through some of them here. Again, a couple of logos that you have seen probably before: Dell, Intel. You see the different network providers. You also see Red Hat, Oracle, and so on and so forth. And you can apply here to become a partner as well. Talking about professionalization and so on, I am working together with the team on creating a course to orient yourself in the quantum ecosystem. So if you are a leader of a technology business unit and you are looking into understanding what is out there in terms of quantum technology, quantum sensing, communication, quantum computing, or if you are actually a co-founder or founder of one of those companies and you want to orient yourself in the market, who else is out there, what is happening, which other companies do exist, or if you are working in venture capital and you're trying to invest into some of these companies and you are looking out for what is happening right now, who's doing an IPO, who is doing a seed round, who is new on the field, then this might actually be the right product for you. And you can find the link to this down below in the video description. So go check this out. I'd be happy to see you, and also later on when we start the learning experience to have a more personal exchange with you and talk about the quantum market. With that, as per usual, I would like to suggest you to stay hydrated as per usual, and I'm looking forward to see you in the next video. Until then, bye bye.